Hey, Mr. Herdum here, Mr. Legend. Yeah, that's me. We're going to go over Unit 14, thermochemistry right now. So what is energy? Energy is the ability of a physical system to perform work. Okay, so basically work and energy have the same units as joules. Okay. Energy can exist in different forms: chemical energy, heat energy, bond energy, but mostly the two broad classes are potential energy and kinetic energy. Those are the two broad types of energies here. The first law of thermodynamics states that energy cannot be created nor destroyed. However, it can be transformed from one form into another form. So you can take chemical energy and you can get motion out of it, you know, like a combustion engine from a car. You can get electrical and you can get thermal out of it because usually those get warm, so on and so on. And there's different forms of energy, of course: light, sound, heat transfer, mechanical motion. So now let's go into depth more about kinetic energy and potential energy. Kinetic energy is the energy of motion. We have a great formula: Ke equals 1/2 mass velocity squared. A formula that you will love in physics, of course. M is the mass in kilograms, and V is velocity. Okay. When you use these units, you're going to get masses in kilograms, and you're squaring the velocity, so it's meters squared per second squared. This is also known as the wonderful great joule. Okay. So, hopefully you remember that temperature is the average of internal kinetic energy. So, the higher the temperature, the more movement there is in the substance. Low temperature, little motion. High temperature, zoom, zoom. High motion. Okay. Now, here we go. Heat. We do realize that heat and temperature are two different things, correct? Heat is just a form of energy, and it does not have a direction. Okay? Temperature is the measure of average kinetic energy. Sometimes you will see them use delta H for heat, which is really enthalpy, but they also use Q, which is also thermal energy. Okay, here's the explanation of this. Delta H is really the heat energy, which is enthalpy, which I think we'll hear that term later. Q is really work. Okay, so from the beginning here, I told you that energy is the ability to perform work. Work and energy have the same units. What are those units? Joules! So, like when you get to physics, when they ask you for the work, they're really asking for the energy, and when they ask for the energy, if you can find the work, yeah, so on and so on. But back to heat here. Okay, is the transfer of kinetic energy from a substance at higher temperature to the system at a lower temperature. Okay, when you touch a substance, it feels hot. Go figure. touching hot substances, it feels hot. It's because the kinetic energy is being transferred from the higher temperature to the lower temperature. Okay. Energy is always transferred from the higher temperature to the lower temperature. Okay, there are three ways to transfer energy, what we call conduction, convection, and radiation. Conduction is for solids. Okay, and these are solids that directly touch. That is how you get the transfer of heat through conduction. So you can see that my hand right here, yes, that's my hand right there, is touching the pan. Okay, since I am directly touching the pan, that is conduction. Okay, what I also like to call conduction, because they directly touch. Okay, convection is for gases and liquids, and this is through current movement. You know, like currents in the ocean, they have movement. Well, gases and liquids have current when they move around, and there's convection flows and stuff like that. The most popular term I use for convection is a convection oven. This heats food through the movement, the flow of gases. Okay. Radiation. This is the transfer of heat through empty space, which includes vacuums. This is how we get warm from the sun, because the heat travels from the sun through the empty space of space and gets to the earth and warms the earth. Okay, the sun is the biggest example here. Okay, pretty much everything gives off a little bit of radiation. This fire gives off a little bit of radiation here, and then you can see here the convection currents I was talking about in the liquid as you heat the water. Okay, so that's kinetic energy right there. Then we have potential energy. Okay, potential energy is the energy that is stored energy. Okay, if you were talking physics, it is based off a position of an object. Usually the formula is mass times gravity times height. And remember that energy can be transferred here, so at the top of the hill, we'd say that there's 400 joules of potential energy. We'd say the person's not moving at the top of the hill, so that would be 0 joules. Well, if the potential energy here is 100 joules, then the kinetic energy is 300 joules. Okay, energy is transferred. It can only be lost in the form of heat. Okay, so I could sit here and discuss physics with you all day because I am a superior physics teacher. But really, I'm supposed to be doing pre-AP chemistry because I'm into pre-AP chemistry notes. So I better be doing some pre-AP chemistry here. So in pre-AP chemistry, and in chemistry too, potential energy is based off of the bonding and or intermolecular forces. If we're talking about chemical changes, we're doing the bonding. If we're talking about physical changes, we're talking about the intermolecular forces. Okay? Okay. I'm going to go over this a little bit better when we do energy diagrams in the next video here. But energy is released when bonds are formed, and energy is required to break bonds. I will do a better job of going over that when we look at the what I call the potential energy diagrams in the next video. Okay. So to break bonds, you need to require energy, which makes sense because if I had a popsicle stick, I need energy to break the popsicle stick. And then when I'm putting it back together, okay, energy is released like that. Okay. Wonderful demonstration for Mr. Harrison. Okay. The overall change in the reaction will be the difference between the total energies of bonds broken and bonds formed. Okay, so we're going to eventually get in a reaction for our equation for delta H. Okay. If the energy required to break bonds is greater than the energy released when bonds are formed, it will be endothermic. If the energy required to break bonds is less than the energy to release bonds, the process will be exothermic, which we will go over better in the next video. And the potential energy is the stored energy. It is stored in the chemical bonds or the intermolecular forces of the molecules. Okay. I am feeling very legendary now. You guys are total champions. The legend is out.